we discussed about principal stress, principal plane, maximum shear stress, plane of maximum shear stress, what is normal stress on maximum shear plane. Okay, so and we discussed a few problems based on those concepts as well. Okay, so today we will now discuss, the simple cases. Like the first simple case is what? If you have uni uni unidirectional stress or uniaxial stress system. Okay, so what is the meaning of uniaxial loading or uniaxial stress system? Anyone? See, if you have load only in one direction, suppose this is a bar and it is subjected to load P. Okay, so my load is only in one direction, so it is known as unidirectional loading, and this unidirectional loading will result in unidirectional stresses or uniaxial stress system. Okay, now my uniaxial loading can be in any direction. It can be in X direction, it can be in Y direction, or it can be in Z direction. Suppose you take a two-dimensional stress system. In 2D stress system, either my loading can be in X direction or it can be in Y direction, right? You guys are agreeing? So this is the case here where my loading is in X direction. Okay, it is in X direction. Now look here, if my loading is in X direction and again I am taking one another coordinate system, which is making an angle theta, okay, with X axis. I want to know what is my stress along S direction, along T direction, and what is my shear stresses in S and T plane. So how we can do? We can use our stress transformation matrix, right? Which we guys have written in last class. Now what you guys see here for unidirectional loading, my sigma yy is 0 and tau xy is 0 when load is acting in X direction. Am I correct? So now you guys write your matrix here. What is your matrix? It is C square S square 2CS S square C square minus 2CS minus CS C square minus S square. Okay, and it is multiplied by sigma XX, sigma YY, and tau XY or sigma XY, and this is equal to what? This is equal to sigma S, sigma T, and tau ST or sigma ST. Am I correct? Is it correct or not, guys? This is what my stress transformation matrix. So those who have missed yesterday's class, I believe they might have gone through recordings. If they haven't gone, I request them to go through recording and try to understand. Okay, and same time I will share this class notes today. Now here you guys look, for uniaxial loading, sigma yy is 0, sigma yy is 0, tau xy is 0. So what will happen? What will be your sigma s? Your sigma s will be only c square sigma xx, c square into sigma xx. My sigma t will be s square into sigma xx, and then your tau st or tau, it is what? Minus cs into sigma xx. Is it clear? Sir, what will be stress transformation matrix for 3D stress system? See, there is something called stress invariant for 3-dimensional stress system. Okay, so that is quite complicated. It can be solved. Okay, it can be solved. There is one, I will share, there is one book called is LS Srinath. So there they have discussed this three-dimensional stress system. The only thing which they may ask in your GATE exam basically is principal stresses for three-dimensional stress system. So we know it can be found, right? Finding eigenvalues. Now yesterday I told why eigenvalues are my principal stress. I missed to tell you guys, so I will tell after this. Now is it clear? Is it clear? These values. So these are what? My stresses on any inclined plane. These are my stresses on an inclined plane. Clear? So what we see here, though my loading is in x direction, but still you have sigma ss, sigma tt and tau st. Even you have what? Shear stress also if you change your angle. So at the same point, if your loading is unidirectional, that doesn't mean in all the direction your stresses are uniaxial. It not necessarily. Okay, it not necessarily you have. That is what the difference between pressure and stress, right? I have told in very first class, my if you take any direction or any angle, pressure remains same, but stresses will change, right? Clear? Is it clear? So you guys can understand here. So many people have this misconception, though my loading is unidirectional, but though my loading is unidirectional, so in any other direction also my stress is uniaxial. It is not the case. Okay, you can have a generalized all three stresses. Okay, this can be seen from stress transformation matrix. Okay, so this is about stresses on inclined plane. Now talk about principal stresses. Now principal stresses will become what? Since you can see there is no shear on this plane, right? There is no shear here or here. What is the meaning of this? What is the meaning of this? Since here shear is 0, here also 0. So what is the meaning of this? These plane are my principal plane, right? So that means whatever this uniaxial stress is what my principal stress. So for uniaxial loading, my principal stresses are nothing but what? Sigma xx comma 0. And what is my principal plane? 0 and 90 degree. Clear? Now you will tell how I will get from formula. You use formula also. What is my principal stress formula? It is sigma x plus sigma y by 2 plus minus sigma x minus sigma y by whole square plus tau xy square. Now in this formula substitute sigma y 0, tau xy 0 and sigma y 0. What you will get? What you will get? One will be sigma x, another will be 0. Is it clear? Same way, is it clear? Any doubt to anyone? Same way, what is my theta? Theta is 1 by 2 tan inverse 2 tau xy upon sigma x minus sigma y. Now your tau xy is 0. That means tan inverse 0 is 0. Right? So theta 1 is 0 means theta 2 will be 90 degree. Clear? So this is how we can verify with formula also. Okay? Okay. So once you know principal stresses, next is what? Maximum shear stress and shear plane. So we know maximum shear stresses. We can use formula also, but before the best thing, always find out theta. So what will be my theta 3? It is minus 1 by 2 tan inverse tau xy upon sigma y minus sigma x. Right? So what you will get? Tan inverse minus infinity is what? Plus infinity. Oh, sorry. Here I did mistake. Guys, wait. It is sigma x minus sigma y, and uh, theta 3 is minus 1 by 2 tan inverse. It is sigma x minus sigma y upon 2 tau xy. Am I correct? This is formula. Now some guy has written plus 45. Nitya, that is wrong. It is not plus 45. Okay, this has to be taken care. So in this case, my theta 3 will be what? Minus 45. Why minus 45? Guys, just a minute. Some problem. Just a minute, guys. Hello, sir. Yeah, yes, sir. Yeah, yes, sir. Hello, guys. I'm audible, right? Okay. Okay. So what we see here, always remember, uh, we best thing is to find the theta. So here theta is coming as minus 45. Okay, minus 45. So theta 4 will be 45. Okay, so theta will be 45. What is the meaning of that? What is the meaning of that? That we have to understand. Here, look here, guys. Can I rub this? Everyone clear? Theta 3 is 45 degree minus 45. Okay, the meaning of this is very simple. See, this is how your initial stress element, then my element will rotate in anti-clockwise clockwise direction. Okay, so this is what my 45 degree, and this plane will be plane of maximum shear. Okay, so this plane will be plane of maximum shear. Now guys, one more thing I want to know. What will be the corresponding normal stress here? What will be sigma here? What will be sigma? Yesterday we have discussed, right? It is sigma xx by 2. It is not just, okay. Why it is? Because we know sigma on plane of maximum shear is given by what? Sigma xx plus sigma yy by 2. Now sigma y is here 0. So it is sigma xx by 2. Now you can see here. Okay. So it will be like this. Your stress element will look like this. And this is how the problem was asked in. Okay, I will use other color. Let me check. Okay, other color. Okay, so is it making sense? Is it making sense? Why this orientation has to be understood? Because in 2020 problem, they didn't ask just value. They asked what? Draw orientation, draw free body. Okay. Now what mistake we do? Here also there is a mistake. Okay, because usually we know the angle between principal stresses and maximum shear stress is 45 degree. Okay, so that's how it is written 45 and 135, but actually it is minus 45 comma 45. It's okay. Okay, now tell me the value, numerical value, find out guys. Is it clear? Can I rub this? Everyone please. Anyone has any doubt here? Let me know. Okay. Now here, so tell me first, what will be my tau? Tau is minus Cs sigma xx, right? Now substitute here. Here substitute what is theta equal to 45 and find out this tau value. I think it will come positive because cos minus is cos, but sine minus is minus sign, so we will get positive value. So this is correct, but this is not correct, so it should be minus 45 and plus 45 degree. Clear? It's clear? Okay, so these are the things need to understand here. Okay, now let's move to next case. Now here you have sigma y non-zero, sigma x 0 and tau xy 0. So this is another case, uniaxial loading in y direction. Now here what will be my sigma s from stress transformation matrix, guys? It is same, right? So what is it? C square s square 2cs s square c square minus 2cs minus cs c square minus s square sigma xx sigma yy tau xy, and here you have sigma s sigma t tau st. Now guys, look here, this is 0, this is 0, so what row will be important? Only this will be neglected, this will be also neglected. So you can see here sigma s is what? S square into sigma y. Sigma t is what? C square into sigma y. Tau is what? Cs into sigma y. Clear? This is clear? Okay. Now, once you know this, stresses on inclined plane, what is next? Principal stress and principal plane. So we know again here 0 degree and 90 degree are my principal plane, and my principal stresses are what? 0 and sigma yy. Now the max important thing is what? Max shear stress. So first you always find what? Plane of maximum shear. So what is my plane of maximum shear? It is minus 1 by 2 tan inverse sigma x minus sigma y upon 2 tau xy. So my theta 3 here, it will be what? It will come 45 degree. Why 45 degree? Because tan inverse here, tan inverse minus infinity is what? Minus, yes, it is minus minus become plus. So it will come 45 degree and then 135 degree. Okay. Is it clear?
Sir, why 90 by 2? 90 by 2, okay. Sigma
What
x
is?
minus sigma x minus sigma y, how it like 90? Like 90 by 2, 45 you got, no?
So you didn't get what why I have written this?
So tau xy is 0, no? So it will be infinity.
Yeah, tan inverse infinity, right? So what is the tan inverse minus infinity, not infinity? Tan inverse minus infinity is what? Minus 90, right? So minus minus became plus. So 90 by 2 is how much?
It should be minus 45, right?
Why minus 45? Minus sign is already there, na? It is like this. Minus 1 by 2, tan inverse minus infinity. So when tan inverse will be tan inverse minus infinity means minus 90.
So why it is minus infinity? It's something upon infinity, right?
No, it is like it is not something upon. It is minus something upon 0. Minus 1 by 0 is what? You can see sigma x comes first, then sigma y comes.
Yes, sir. So how it's minus?
So 0 minus something by 0 is what?
Okay. Here sigma x 0, right?
Yeah.
Okay.
Is it clear? I think now it is fine. Yeah. Okay. So we got angle 45 degree and 135. Now find tau max. Now tau max is what? It is it is CS sigma yy. Now what is theta? 45 degree. Clear? So what is your tau max? It will come sigma yy by 2. What is corresponding normal stress? It will be sigma yy by 2. Right? Now draw the orientation. If you draw now orientation, is it clear? Can I draw orientation now? Anyone has any doubt here? Any doubt? Okay, now means let's go. So see, it is very important to understand this orientation. Okay, now this is what initially, right? You have sigma y. Now my plane of maximum shear is what? 45 degree, right? So this is what? 45. So if you draw now, your stress element will rotate in anti-clockwise direction. Now here my stress is sigma yy. Now my corresponding shear stress will look like this. Clear? Now one more thing is there. One more thing, on plane of maximum shear, your both, yeah, it is anti-clockwise direction, right? Because theta is positive. Now here one more thing, always on plane of maximum shear, your normal stresses are same at 0, what I mean, on two perpendicular plane. On this plane also and this plane also, you can see it is also sigma y, it is also sigma y by 2, not sigma y, it is by 2. It is not clockwise, it is anti-clockwise now. You, how you can understand it is anti-clockwise? You understand by this way. See, this is what my positive s direction, this is what t direction. So since this is positive s direction, so my corresponding shear is going in this direction. In the previous case, it was not like this. Okay, I will draw the previous figure also. Nitya, is it clear? Yeah. Is it clear to everyone this figure? Now I will tell you what is the difference between this figure and the previous figure. Okay, let's see that as well. Okay, let's see that as well. Okay, can I clear this figure? Okay, now go back the previous case. Okay, so this is what my sigma x, this is what my sigma x. Now take some different color. So this is the initial orientation, then I got theta negative, so it rotated like this. Now since it is rotated like this, so that means this is my positive s direction. Okay, so this is my positive s direction, so I got my shear like this and I got my shear like this. You can see normal stresses somehow look similar, but what you are seeing the change, the way shear stress acting on this is different from the previous case. This is just due to change of orientation. Okay, now you will get this if the previous one you rotate by 90 degree in clockwise direction, you will end up with this. Now if you rotate this by 90 degree in counterclockwise direction, you will get the previous one. Clear? Okay, fine. So now move to next case, biaxial stress system. Now, why I am discussing all these cases? Because in your GATE exam, most of the your problem will be from uniaxial, biaxial, or pure shear case only. They will not give a complicated two-dimensional stress system. Okay, we will see that in problems. So look here. When you look here, you have now two stresses. Okay, but there is no shear. Now tell me, if there is no shear,
Sir,
yeah,
sir,
Lovin.
sir, in that previous where sigma y is there, sir,
Hmm.
it should be rotated clock like 20
Counterclockwise, no?
counterclockwise, no? Like in the
Yeah.
question you told yesterday, like
The last question that was rotated in clockwise because theta was negative.
yeah, here it is positive, so counterclockwise.
Yes, exactly. And that's how we have derived our formula, considering a counterclockwise angle. When theta
Okay,
was positive, okay?
okay, okay.
Okay. Now, biaxial stress system. So tell me here, what is my principal stresses? Okay, before that, let's discuss now stress transformation. So stress transformation, how it will be? It is C square S square 2CS, C square, sorry, S square C square minus 2CS minus CS CS C square minus S square. It is sigma X, sigma Y, tau XY. Now it is what this side? It is sigma S, sigma T, tau ST. Now look here, what is 0? Only tau xy is 0. So that means this row will not be useful, but these two will be. Now what is sigma s? It is c square sigma x plus s square sigma y. You can see sigma x c square plus sigma y s square. What is your sigma t? S square sigma x plus c square sigma y. What is tau st or tau? Minus cs sigma x plus cs sigma y. Is it clear? Is it clear? Is it clear to everyone? Okay, I think it is simple. So all of you can practice this. Okay. Now you know your this one stress transformation or stresses on inclined plane. What is next? Principal stresses. So I know for this case, what is my principal stresses? What is my principal stresses? Since here there is no shear, right? That means my sigma xx and sigma yy itself are my principal stresses, and my principal plane are what? 0 and 90 degree. So this is what you guys can see here, 0 and 90 degree, and sigma xx comma sigma yy. Now what will be your maximum shear stress? What will be your maximum shear stress? So first find out angle. So what will be your theta 3 minus 1 by 2 tan inverse sigma x minus sigma y by 2 tau xy. Now guys, this in this case my theta will absolutely will depend on magnitude of these two. You cannot say directly plus 45 or minus 45. Is it clear? In this case, my theta is 45 or minus 45 will depends on the magnitude of sigma x and sigma y. If sigma xx is greater, theta is minus 45. If sigma y is greater, theta is plus 45. Clear? So here there are two cases. So don't write this. This is wrong. What we say? Theta 3 is plus 45 if sigma y is greater than sigma x, and it is minus 45 if sigma x is greater than sigma y. Is this statement is correct? What is the value? Tau max value is sigma xx minus sigma yy by 2, or you can use formula and you can find out. Okay, so again value will be again depends on what? It will depends, it will be either sigma xx minus sigma yy by 2, or it will be sigma yy minus sigma xx by 2. In both the cases my value will be positive, tau max will come positive. So my theta 3 is plus 45 if sigma y is greater than sigma x, and it is minus 45 if sigma x is greater than sigma y. Okay, now guys, if it is minus 45 degree, then also what you will get? What is your tau? My tau is minus cs sigma xx plus cs sigma yy. Now if it is a minus 45, then this will be sigma xx minus sigma yy by 2. When it is plus 45, then it will be what? It will be sigma yy minus sigma xx by 2. That means this is also positive, this is also positive value. Okay, so in both the cases you are getting tau max as positive, because for my this case sigma x is greater than sigma y. For this case, which is here, sigma y is greater than sigma x. Clear? Okay. Now here I will not draw orientation, because you guys already understand how to draw orientation. Okay. Clear? Anyone has any doubt here? Malav, are you there? No. Netra is also not there. Anyone? Okay, that's good. Fantastic. So last, which is most important case is what? Pure shear. Last, which is most important case is what? Pure shear. Now pure shear case is what? You know the torsion of shaft. So the torsion of shaft is the case of what? Pure shear. The pure shear means you can see here my stress element at a point there is no normal stress. If you do normal stresses, they all are zero. So in this case, what happened? Write stress transformation matrix. What you will see? Write stress transformation matrix. Sigma S, sigma T, tau ST or tau is what? C square S square 2CS, S square C square minus 2CS minus CS CS. Now here guys tell me this is 0, this is 0, right? So that means first two rows will not be, first two column is no use. Clear? Now then tell me what will be your sigma S? It will be 2CS tau xy or sigma xy. Sigma T is what? Minus 2CS tau xy. What is your tau st or tau? It is C square minus S square into tau xy. Now what is the misconception people will have? Pure shear means there is no normal stress, right? People thinks like that. Is it clear? What people think? Pure shear, there is no normal stress, but there can be normal stress if you rotate this element by any angle theta. If you rotate this in clockwise or anti-clockwise direction, hello, I am audible, right? So if you rotate clockwise or anti-clockwise, you will see there is a normal stress. What is that? It is given by 2CS tau xy and another is given by what? Minus 2CS tau xy. Is this point clear? If now someone asks in interview, you go for any job interview, they may say if you have a torsion of shaft, okay, will you have a normal stress? Basically, in the plane where you have pure shear, you will not have, okay, but if you change your orientation of stress element, you will have non-zero normal stress. What I can tell further, if you have a pure shear case, will you have principal stresses? For pure shear case also, we can have a principal stress, okay, at a point. Okay, so you can have a principal plane also. So these are the important thing here. Now you know stress transformation. Next is what? What is my principal stresses? So what is my principal stresses for pure shear case? Guys, tell me. This is my pure shear case. So first find out theta 1. What is my theta 1? It is 1 by 2 tan inverse 2 tau xy upon sigma x minus sigma y. So what is my theta 1? My theta 1 will be positive, guys, here, means plus 45. What will be theta 3, theta 2? 135. Now what will be values? What will be your principal stresses? It will be plus minus tau xy. It is plus minus tau xy. Now if you draw here free body, so how it will look like? It got rotated in counterclockwise because theta is positive. So draw it. So here, what is my value? Plus tau. But here, it is a minus tau. And what is my maximum shear values? What is the maximum shear values you are getting? You will get tau only. That we will discuss. Okay, let not go into that part. So is it clear? Principal stress part is clear. Okay. I was making mistake. What mistake I was making, guys? Tell me what mistake I was making. Anyone? Can you have here any shear stress? Anyone tell me, can you have any shear stress here? No, it cannot be because these are principal plane. So I was doing mistake in hurry. You cannot have shear stress on principal plane. So you should have this figure exactly like this only. Okay, clear. So done. Now look, what will be plane of maximum shear? It is theta 3. So theta 3 is what? Minus 1 by 2 tan inverse. It is what? Sigma x minus sigma y upon 2 tau xy. Now this is 0, this is 0. So what? Tan inverse 0 minus or plus, it is 0 or 360 degree. It is same, right? So it is 0 and 90 degree is what my maximum shear stresses. Plane of maximum shear is what? 0 and 90. What is the value? You will get tau itself. Means the plane of pure shear itself is what? Your plane of max shear. So I can write plane of pure shear is what? Plane of max shear. Clear? So is this clear? Okay, now tell me, yesterday I gave some homework. Anyone has done homework? Good, Nitya. Others? Yeah. So yeah. So that means when you do those exercise, all the concept will be clear. Okay. If any doubt, you guys can ask me. Raman, I gave some homework. We have done some derivation and I asked students to do other derivation part. Okay, fine. Raman, see, at IGC, it's more about learning. Okay, personally, me, don't worry in that depth. Yeah, in depth is there. I will solve now gate mechanical questions. If you know in this much depth, you will not do any mistake. On this concept, pure shear only, they have asked twice 2 questions in gate mechanical. I'm going to show directly you that question. Okay. Now one more thing I see. See, for me personally, vision is very clear at IGC Raman. See, always try to become a better engineer. Of course, gate is part of our life. Okay, we have to do very well. But if you know any subjects in a good depth, not just me, either you take Rishi sir, Naveen sir, or any sir. Our focus is what, learn basics well, learn for forever. Okay, always you will remember whatever we have taught. Okay, even whoever got succeeded either in DRDO or in any other interview, they still remember. My student went for DRDO interview. They asked, tell me, uh, uh, tell me, what is total strength? What is total strength? They asked to him for DRDO interview. Now he is in Semilac lab in Bangalore. So after 2 3 class only I will teach you what is total strength. Generally they will say it is a strength like stress by area into modulus, sorry, it is stress by modulus of elasticity, right? Hooke's law, something like that they will tell. Mostly what will tell, what is total strength, guys? What answer you guys will tell? What is total strength? I am asking all of you. What is total strength? I am asking all of you. It is change in length to original length is what is strength. Generally, it is the definition of strength. See, okay, quickly I will answer. What is the meaning of total strength by any person? See, strength can be developed due to mechanical loading also. No, it is not like that, Paul Thomas. And it can be due to thermal loading also. So my total strength is always summation of mechanical loading plus thermal loading. Now on top of that, what Hooke's law is only applicable for mechanical loading. It is not applicable for thermal loading. Whatever you say na, stress is proportional to strain, is only for mechanical loading. So my total strain is what, mechanical strain plus thermal strain. Thermal strain, it doesn't depends on cross sectional dimension. It is what, epsilon T is what, alpha delta T. It is only function of temperature and modulus of thermal expansion coefficient or thermal expansion coefficient. It doesn't depend on E, modulus of elasticity. But your mechanical strength, if it's a unidirectional loading, epsilon is or sigma is proportional to epsilon, right? So what is epsilon? It is sigma by capital E. Okay, so that's how we have to understand, everything in sequence. Okay, so he answered, my total strength is simply summation of mechanical and thermal strength. Okay, we will do more interesting things there. Okay, and the way we will be doing it is not mentioned in any of the book, thermal stress part. Okay, so it will be useful to all of you. Let's now move to problem, because Raman is telling such questions they ask or not. Okay, we will come. Yeah, now you can see yesterday's question, guy. Yesterday's question, you can see option B and option D. What is the difference between option B and option D? Guys, tell me the difference between option B and option D. It is the direction of tau. It is just direction of shear. So I made it clear yesterday, right? Your stress element got rotated in clockwise direction. So this is my positive S. So my corresponding shear should also go in positive T direction if tau is positive. My tau was positive 5. So it should go like this. But here you can see it is going in negative T direction, which is not correct. Now I gave this also as a homework. I gave this also homework. कि you do reverse from this, find the sigma x, sigma y, tau xy. From this also find out sigma x, sigma y and sigma xy. Anyone has done this? Has anyone done this? So from which you got whatever the given was? Only from option B. Okay, so that's what. Now come to another some good problem. Okay, so the answer is given. Yeah. Now Raman, look into this problem. Problem number second is from Gate ME. Now whatever most of the mechanical student, what they do, they will study Ramamrutam, Khurbi, Masal, like that, right? Raman, am I agree? Even in Delhi, people study these books only. Rapamrutam, Khurmi, Bansal, Das, this, that. Now, no book draw stress system in rectangular form. Hardly any Indian author draw stress element in this rectangular form. Why? They always write it a triangle only. They solve all the stress transformation problem using triangle only. Why? Raman, tell me this. We should not understand stress transformation keeping just, this is just triangular element, get some formula, not that way. Now try this guys problem, this problem, you will understand. This is the pure shear problem. I am saying hint. This is the pure shear. Tell me the answer. Why it is pure shear? You guys have to give me the answer. Okay, give me solve this. Meanwhile, I'll come back to class. Raman, what is the answer for this? Please solve this problem. Then we will discuss. So guys, tell me what is the answer. So let's do poll. Yeah, Arati, you got C is the answer. Subhashini, you are also getting C is the answer. Why? Others, can you guys quickly? Sanjana, Priyanka, Paras, you never answer. Why? See, I do not want such a student. Okay, you have to respond. Yesterday also I have seen you are not answered. So it seems you are not in class, or where is that guy? Paras, respond on this quickly. No, stress transformation also you use, you will get B only. I will tell you. Okay, we will use stress transformation also. Okay. Okay. So I think B should be the answer. B is the answer, but some guy will just keep mic and they will run away. Okay, so let's look here. So I think Paul says B is the answer, and we will see how B is the answer. Okay, let's first do by stress transformation matrix. So you guys are saying with transformation matrix you are getting C is the answer. So let me do. Now here, if you see the figure, first read the question. What it says: the state of stress at a point on an element shown in figure. So here I can see my stresses are given in inclined coordinate. The same state of stress is shown in another coordinate system B. Now what they want this tau xx, tau yy and tau xy. So initially I told what is the tau xx? Is it normal or shear stress? Guys, is it normal or shear? It is a normal stress, right? It is a normal stress. Okay, that's good. Now here, guys, now my stresses are given in inclined. Okay, in inclined. This is what in inclined. So you can see here, what is my theta? It is 45 degree. And what is my stress? Sigma s is P. What is your sigma T? Minus P. What is your sigma st? It is 0. This whole data is not going. Okay, anyway, no issue. So now here, if you write transformation matrix, what it is? Tau xx, tau yy and tau xy. Now tell me guys, which transformation matrix I will use? Second one. You guys remember? We will use second one, because here unknown, yeah, inverse one, exactly, because here known are in inclined one. So it is what? C square s square minus 2cs, then s square c square 2cs, then cs minus cs c square minus s square. It is what? Sigma s, sigma t, tau st. Is it clear? It is visible to everyone? Yeah, now tell me. Now Priyanka and sorry, what is your name? Subhashini, Arati, tell me. What is the correct answer? So even theta is not required to substitute. Here my tau st is 0. So what is your tau xy? It will be it will be C square into sigma S, which is how much? P. Then minus S square into P. Now what will be, this is what tau XX. Tau YY is what? It is S square P minus C square minus P. Then tau XY will be what? It will be CSP plus P into CSP, because minus minus became plus. Now here I know, since theta is 45 degree, so my C square will be S square, because cos 45 sin 45 is same. So this is 0, this is 0, and this will be what? 2 CSP. Now since theta is 45, so it will become 2P by 2. It is what? P. Now tell me, what is the answer? Those who did by transformation matrix. So you guys have to be careful. You guys can use transformation matrix. Raman, are you there? I think he might have got disconnected. Okay. Yeah. Here tau st is 0 na, in this figure. You can see na, in figure there is no shear stress, right? Only you have normal stresses. Okay. Now without these all, also you can say like this. You can see, whenever you have pure shear case, whenever you have pure shear case, right? So for pure shear case, what is my principal angle? It is 45 degree. And what is your principal stresses? It is plus minus P, right? So you can see here, see, this is corresponding to what? This. That means in X and Y direction, it is what? Pure shear case. So this is clear. If you understand pure shear case without using any formula, you can answer this question. Now one more trick I will give. What is one more trick? You guys can check, is it correct or not? I think one more trick is there. Okay, but that will be satisfied this and this. Okay, so this is the easiest way. Yeah, another trick is like this. What I want to say, you know, summation of normal stresses. Guys, you know what is your principal stress? It is sigma x plus sigma y by 2 plus minus this sigma x minus sigma y whole square by plus tau x. Now if you add this sigma plus 1 plus sigma 2 by 2 will be always equal to sigma x plus sigma y by 2. Or what you can say, the summation of normal stresses remain constant. You take any orientation, if you change from 0 to 360 degree any orientation on two perpendicular plane, your summation of stress will remain same. What I mean, you took this, right? Initially x and y. Suppose I take a new also, this s and t. What will happen? Sigma x plus sigma y will be equal to sigma s plus sigma t always. Now here you can see, if I sum this p and this minus p, what I will get? Sorry, this minus p and plus p, you will get 0. That means your normal stresses should be 0, 0. then only you can have this case. See, if you have non-zero, right? If it is a non-zero, what will happen? If it is a non-zero, you cannot have summation as 0, right? Okay, so these are the two way to solve this problem. Okay, let's now discuss next problem. Anyone has any doubt here? Okay, so let's move to next problem. Try guys this problem number third. This is again a good problem and it is from gate mechanical. What is given? So this can be also solved by two way. Okay, the one is shortest way. What is given? In a plane stress problem, the principal stresses at a point are 30 megapascal and minus 15 megapascal. Okay, I'll zoom. Yeah, now you guys can see at the same point on an element whose sides make an angle of 45 degree with respect to principal axis, the normal stresses are. So what you guys see, they have given one stress element where my normal stress is 30 and another is minus 15. So my shortest way is what? This 30 minus 15 should be any you can add and you'll see the only option A will be given by what? 15 by 2 plus 15 by 2 is what? 15, and this is also 15. Right? Other options are not satisfying this condition. So this is the shortest, but you can have one option where what I'm saying, you sum it this plus this and check all four options. There is only one option which gives, because this is going inward, so minus 15, right? So 13 minus 15 summation is how much? What was my hypothesis? Sigma x plus sigma y is equal to s plus sigma t, right? So only A answer satisfy this condition. That is the one way. Okay, other way we can use transformation matrix. Now here is one thing is confusing. They told it makes 45 degree angle with principal axis, but we do not know it's a clockwise or anti-clockwise. We do not know it is a clockwise or anti-clockwise. But what is the given thing here? They only asked normal stresses. They did shear stress. So my normal stress not depends on orientation, because you write stress transformation matrix. What will be your unknown is suppose as sigma t plus t. It will be what? It is c square s square 2cs s square c square minus 2cs minus cs c square minus s. Here what happened? you only have sigma x, this y, and tau xy is 0 because these are my principal stresses. Now here guys, since I have only to find sigma s and sigma t, then only these are important. So no, they haven't said plus 45 degree. Where they have said 45 plus 45 degree? They told it makes 45 with respect to principal. Consider generally the direction counterclockwise angle is positive. That way we can say. Is that voice breaking? Okay, okay. Just wait. Is my voice is audible now? Yeah, it's audible, right? It's breaking. Okay. Now, yeah, is it clear voice now? Yeah, fine. So what I was discussing, okay, anyway, we will not go. We consider theta 45 positive, okay? Then what I got, what is my sigma s? I'll get from here my sigma s, c square sigma x plus s square sigma y. And what is your sigma t? It is s square sigma x plus c square sigma y. What is your sigma x here? Sigma x is 30, sigma y is minus 15. Guys, solve it. You can do stress transformation and solve it, right? So do polling. Yeah. So what is the answer? Again, who all are not answering? Raman, Paras, Naveen, Murugesh, Anusha, Amit. You all can answer. Why you guys are not answering? Okay, let me take picture. Okay. Hello. Yeah, I am audible, right? Okay. So let's publish the poll result. Anyone has any doubt here? But in polling you are not answered. Okay, anyway, A is the answer. Yeah, at least you are there in class, you are responding. But there are people, they will just connect audio and they will, will keep and do something else. Okay, let them do. Okay, next. Guys, this is very simple problem. So what they asked, in the plane of in the plane of in a plane stress condition, the component of stress at a point are sigma x 20 megapascal, sigma y 80 megapascal, and tau xy 40 megapascal. The maximum shear stress at a point. So what is the maximum shear stress? Now here you can find theta and you can find a tau, or you can directly write formula and you can find. So it is sigma x minus sigma y by 2 whole square plus tau xy square. So how much it? So direct formula based question came in GATE. Okay, 50 is the answer. Again, Paras, I am asking you to answer. I think he is not there in class, it seems. Okay. Okay, can we move to next question? Yeah, read the problem. What is there? The state of stress at a point is given by sigma x, sigma y, tau xy. The maximum tensile stress at the point is. Now guys, tell me, what is the maximum tensile stress? It's a normal stress, right? So it is one of the principal stress. Now find out principal stress and tell me what is the maximum tensile stress. Find out principal stresses. So there are two methods, right? One is what? Matrix method. So it will be minus 6 minus lambda, then minus 8, 4 minus lambda is equal to 0, and find out lambda values. Now another method, sigma 1 comma sigma 2 is what? Sigma x plus sigma y by 2 plus minus. Find out, guys. But tell me, which is the maximum principal stress? What is the maximum principal stress here? Maximum principal stress. It's a positive. No, maximum principal stress means by magnitude or major principal stress. Hey Dinesh, how you are getting 6? Check your calculation. What is your principal stresses? Tell me here. There will be two, right? What are those two value? One is 8.466433. Another one? Yeah, sigma 1 and sigma 2 I am asking. What is sigma 1 more? Exactly, it is minus 10.433. Now someone asked, what is your major principal stress? Tell me, what is your major principal stress? What is your major principal stress? Is it this one or this one? What is your major principal stress here? Exactly, major principal stress has to be by magnitude. Okay, so your answer should be this, but in question they asked what? Maximum tensile stress. So maximum tensile stress is what? This 8.433. Okay, because they asked tensile. Tensile means positive. Okay, so be clear between, what is the meaning between max tensile stress and major principal stress? Yeah, 10.433 is compressive, but since it is a more by magnitude, so it is known as major principal stress. And your 8.433 is what? Minor principal stress, which is lesser by magnitude. Okay, so now is it clear? Can we move to next problem? I think next two problems we have already done. So this principal stress problem we have done yesterday. You guys know we have done this problem using matrix method. This problem also we have done. Any doubt in these two problems? Okay, so I think these problems are done. Okay, now we have discussed, all the cases which are related with, stress transformation, principal stresses, principal plane, max shear stress, plane of max shear, normal stress on plane of max shear, uniaxial, biaxial, pure shear. Now next is what? Graphical way of finding stresses. Okay, or graphical way of representing stress system. So what is that? Graphical way of representing stress system is known as Mohr circle of stress. So it is what? Graphical way of representing stresses. Now to represent this graphical, what we consider? We have considered the same stress system which we have used previously, for stress transformation. You guys know, right? This is what my triangular element, right? Am I correct? Okay. Now, when we draw Mohr circle, what we do first, we have some sign convention. So what is the sign convention says? All my tensile stresses, all my tensile stresses are drawn on positive x-axis. So all your tensile normal stresses are drawn on positive x-axis. Now, if it is a compressive stress, then what we will do? We will draw it on negative x-axis. Your x-axis is also known as what? Abscissa. Your y-axis is known as what? Ordinate. Okay. Now, this is about normal stress. Now, what is the sign convention for shear stress? For shear stress, we say if my shear stress try to rotate my element in clockwise direction. If my shear stress try to rotate my element in clockwise direction, then it is drawn on positive y axis. If my shear stress try to rotate my stress element in anti-clockwise direction, then it is on negative y axis. Is it clear? This sign event convention is clear. So if it is trying to rotate clockwise, then positive y axis. If it is anti-clockwise, negative y axis. Okay. Now let's look here. We are drawing more circle. How it is drawn? Okay, I'll just okay. Is it now visible? Is it now visible? Okay. Okay. All right. So you can see here all positive normal stresses are on positive x-axis. All shear stress which try to rotate element in clockwise direction are on positive y-axis. So this sign convention is clear. Now look here. I will write my stress element here. This is what my stress element. Now here, this is what my sigma x. This is what my tau xy. This is sigma y. This is my tau xy. This is my unknown sigma, and this is why my unknown tau. Now, what we do when we draw more circle, we will measure all these quantity, all the stresses on a scale. Okay, on a scale means suppose it is a 10 megapascal, we can assume it is what? 10 centimeter. So 1 megapascal is what? 1 centimeter. Have you guys done this exercise in your BTech? More circle, drawing more circle using, you know, this compass, scale, right? So whatever we have done from mathematical formula, same thing can be done using compass also. But anyway, in your GATE exam, they will not ask draw more circle using compass. Will they ask like that? They are not going to ask. But we will study and we will understand the importance of Mohr circle. Okay, they may ask some theoretical questions from Mohr circle. Anyway, I will show one of the GATE problem, what kind of problem they may ask from Mohr circle. Okay, so that's not an issue. So what we do here, now here I am assuming my sigma x is greater than sigma y by magnitude. Okay, my normal stress sigma x is greater than sigma y, and both sigma x and sigma y both are tensile. Both are tensile. Now we assume sigma x is some length OA and sigma y is some length OB. Okay, so what will be your AB? AB will be what? OA minus OB or OB minus OA. Here actually we have assumed sorry, sigma x, yeah, correct only. You can see here, right? So AB is what? Sigma x minus sigma y. So what is your AB here? You can see in picture. This is what? Sigma xx. What is this? Sigma yy. So this is what your AB, right? This is what your AB. Now look here. This is what your sigma x. On this plane there is a corresponding shear and it is going downward. Now this downward shear will try to rotate this element in what? Anti-clockwise direction. Am I correct? It will try to rotate it in anti-clockwise direction. Is it correct? Anyone has any concern here? Right. So that means here it will be drawn downward. So this is AP2 is what? My this stress, which is what? Tau xy. Now look here, on plane where you have sigma y, my shear is going in this direction and this shear will try to rotate your element in clockwise direction. Is it clear? So here you can see it is going up and it is what? BP1. Everyone, is it clear? Now what we can do, we can match this P1 and P2. When you match P1 and P2, this will intersect your x-axis and that point is known as center of Mohr circle. Where P1 and P2 intersect is known as point C and C is what? Center of Mohr circle. Now what is your AC? Your AC and BC is what? Equal, because C is what? Center of AB, and so AC is equal to BC is equal to what? AB by 2. Clear? Is this clear? Is this clear? Okay. Now guys, I will rub these things. Okay, I'll rub. What I can see here, I know AB and AC, right? So what is my AB and AC? This distance. Then I know this distance. What is that distance? AP2. AP2 is what? Tau xy, right? So what is this? CP2 or CP1? Anyone? What is CP2 or CP1? CP1 or CP2 is nothing but radius of Mohr circle. And what it is actually? It is a square root of AC square plus CP2 square. So it is nothing but sigma x minus sigma y by 2 whole square plus tau xy square. And that is nothing but tau max. So is it clear how we found radius of Mohr circle? Now since you know the radius of Mohr circle, what we can do? We can draw a circle with radius r, right? Now you can see this is the what? maximum value, right? So tau maximum is nothing but what? Radius of Mohr circle. That anyway we will discuss later. So once you know radius, what is next? What is the center of Mohr circle? Tell me. What is the coordinate of center of Mohr circle? So center of Mohr circle is what? It is OC comma 0. Right? Now tell me what is the OC? OC is OB plus BC. What is your OB? It is sigma y. What is your BC? Sigma x minus sigma y by 2. So what we got? Sigma x plus sigma y by 2. And this is what? This is the normal stress on plane of max shear. Right? This is what? Normal stress on plane of max shear. And you can see a corresponding to OC, your shear is maximum. Clear? Is it clear? Clear? Okay. So we got what? We got radius and we got what? Center of Mohr circle. Now, what next we can do? We can find principal stresses and principal plane. So what is my principal stress? Look here. This point O, right? So it is the furthest aft point, right? So my furthest aft point is what? D, right? So my sigma 1 is what? OD. What is your OD? My OD is always OC plus CD. What is CD? CD is R and OC is what? Sigma X plus sigma Y by 2 plus R. So this is what my first principal stress. Is it clear? Now what is your second principal stress? Which is what? The minimum value, right? So what is the minimum value here? It is OE. Now what is the OE? OE is what? OC minus R. OC minus R. So what is the OC? It is sigma X plus sigma Y by 2 minus R. Yeah, anyone want to say something? Yes, Raman. Where were you all these times? We were calling you. You went for dinner? Sorry, lunch? You know, there are guys, while writing test, online exam, they go for lunch. One day in 2019 sometime, one guy wrote one exam and I saw for one question it was 30 minute, around 20 minute. I told, what you were doing, man, for the one question itself, you know, around 20 minute. He told, sir, I went for breakfast. So that's then I told, you can go in gate exam also for breakfast. Okay, they will give you extra time. That's what the sincerity. Okay. So guys, there is no meaning you keep, you know, mic on and you know, go for lunch. Okay, I can assume if there is no response when I call 5 times, that means that guy is not present there. Okay, all right, not an issue for me anyway. Okay, So we got principal stresses. Now one important thing which I want to explain, I will erase everything here. Now how you will measure your theta 1 and theta 2 from here? What will be my reference plane? Tell me guys. In this mode circle, what will be my reference? What will be my reference plane? Or what will be my reference? Anyone? And from which okay, so here always remember exactly CP2 will be my reference. Always CP2 will be my reference. Okay. So my first angle is what? It is 2 theta. This much only. Okay. Again, I will I'll write in some color. You can say this is my reference, and my angle from this reference to x-axis to x-axis is what? 2 theta. Okay. So what we see here, this triangle, right? This triangle. So this is what? 2 theta 1. This is what? Radius r. This is what? Sigma x minus sigma y by 2. Because this point is C. This point is A. This point is P2. Now tell me, what is tan 2 theta here? It will be what guys? And this is what your tau xy. So what is tan to theta 1? It is tau xy upon sigma x minus sigma y by 2. Right? Now in diagram it won't be bit clear till you get diagram. Now I have drawn outside. Now is it clear? Now I have taken the triangle out and I have cleared. Yeah. So now this is what we have derived, right? We have derived already. What is your theta 1? 1 by 2 tan inverse 2 tau xy, or let me write here 1 by 2 tan inverse 2 tau xy upon sigma x minus sigma y. Clear? So this you guys can see here. Now you can see here in mode circle here itself. If this is 2 theta 1, then this total is how much? 180, right? So your 2 theta 2 is what? 2 theta 1 plus 180. So what is theta 2? Theta 1 plus 90. Is it clear? Okay. Now you got principal stresses, principal angle. Next is what? Maximum shear stress, right? So maximum shear stress is nothing but radius, right? Now again, my angle will be measured from what? This reference. Now you can see this angle is what? 2 theta 1. This is what? 90 degree, right? So my 2 theta 3 is what? 2 theta 1 plus 90 degree. So what is my theta 3? Theta 1 plus 45. Is it clear? This is what we derived in initial classes mathematically, right? Tan 2 theta 1 into tan 2 theta 3. If we multiply, it comes minus 1. Clear? Is it clear? So you know now angle is how much? Theta 1 plus 45 degree. Okay. So we can see here, and theta 4 is nothing but theta 2 plus 45 degree, or theta 1 plus 135 degree. Now next is important to find stresses on inclined plane. Now look figure I have drawn further again. So now you want to find what? This sigma and this tau, right? Which are on inclined plane. And this inclined plane is making what? Theta angle. Okay. Now this theta angle, so how you will find that? So what we can do here, again you can see we have drawn more circle, and here my reference is what? CP2. I'll measure one angle which is 2 theta. Okay, this angle is what? 2 theta. Now you can see this is the coordinate, right? So this coordinate of this point is nothing but what? Your sigma s comma minus of tau st. Now tell me why minus sign is there here. Tell me guys, why minus sign is here? You can see here this tau which is going in this direction, try to rotate it in what? It is trying to rotate it in anti-clockwise direction. So it is what? Negative. But it is shown here. It is shown on what? Positive y direction. So we are substituting, minus sign here. Okay, otherwise you will not able to derive this. Your formula will not match. Clear? Why this minus sign is there? Okay, I'll repeat it one more. You can see in this figure, my this tau will try to rotate it what? It will try to rotate it counterclockwise. So that means this tau is what? Should be on negative y axis. But we are here seeing this coordinate of point Q is what? Sigma s comma minus tau st. Okay, because your tau is drawn on positive y axis, so we are substituting negative sign. Okay, now look here, this is like this. Here you have one angle which is what? 2 theta 1. This is what? Another angle 2 theta. Right? Then what will be this angle? Am I correct? So you can see here, this is one triangle where the angle is what? 2 theta minus 2 theta 1. This point is what? Some point P. This is Q, and this is what? C. Now this is another triangle which already we know previously, 2 theta 1. So I can write here sine 2 theta and cos 2 theta. So sine 2 theta 1 is what? Tau xy by r, and cos 2 theta is what? Sigma x minus sigma y by 2r. Right? Now use this triangle. Use this triangle. What will be your QP? What will be your QP? Tell me. It will be r sine 2 theta minus 2 theta 1. Am I correct? And what is your QP? It is minus tau st. Am I correct? What is QP? It is minus tau st, right? Because it's a coordinate, right? Now, what is sine A minus B? What is sine A minus B? Sine A minus B is what? Sine A, sine B minus cos A, cos B. So sine 2 theta minus 2 theta 1 is what? Sine 2 theta cos 2 theta 1 minus r cos 2 theta sine 2 theta 1. Now here I can substitute what? Cos 2 theta 1 and sine 2 theta 1. Substitute here, and this is already equal to what? Minus tau st. So you will see the finally your equation which you have derived mathematically. Tau is what? Minus of sigma x minus sigma y by 2 into sine 2 theta plus tau xy cos 2 theta. Right? This is what mathematically we derived. So the same thing we have got it from Mohr circle. Is it clear? Is it clear? Okay. Now the last thing which we will discuss. Now here, look here. This distance is what? CP. So what is CP, guys? What is the CP? CP will be r cos 2 theta minus 2 theta 1. Am I correct? And what is OP? What is the OP, guys? OP is nothing but your sigma. This distance is what? Your sigma. The x coordinate is what? The x coordinate of point Q is what? Your sigma. Am I correct? The x coordinate of point Q is what? Sigma, and which is what? OP. Now OP is what? OC plus CP. OC plus CP. So you guys can see here. OP is what? OC plus CP. CP is r cos 2 theta minus 2 theta 1. And again expand it. Substitute cos 2 theta 1 and cos 2 theta 1. You'll get this. And this is what the equation which we have derived earlier mathematically. So this is what? Mohr circle of stresses. Okay. So we will continue the remaining discussion in next class. So a small half an hour is pending, and then we will move to next topic, strain. Okay. Is it fine, or should I continue? I think it's done. You guys have, classes for morning. Yeah. So let's do remaining in next class. We will do, and then we will move to. We discussed about stress transformation, then we discussed about principal stress, principal plane, maximum shear stress, plane of maximum shear stress, what is normal stress on maximum shear plane.